Conditional probability. In a multi-stage experiment, each stage can reveal more information about the world and thus changes our probability function. In this example, I first roll a die and then toss a coin. Before I roll the die, all 12 outcomes are possible. After I roll the die, and let's say the die shows 2, then only 2 of the 12 outcomes are possible. An event B is given if we observed it. That means the event really happened. There's no more uncertainties. This notation stands for the probability of A given B. Try the following exercise. Let's look at the first statement. It said, probability of B given B is 1. This is true because B already happened. The second statement said, probability of A given B is a number between 0 and 1. This is true because probability is always a number between 0 and 1. The third statement said that if A intersecting B is the empty set, then the probability of A given B is 0. If you think about it, A intersecting B is the empty set means that A and B can never happen together. So, given that B has happened, the probability of A happening is 0. So this statement is true. The fourth statement said, if A is a subset of B, then probability of A given B is 1. This statement is false. See if you can come up with a simple counterexample. The last statement said, if A contains B, then the probability of A given B is 1. This statement is true. In general, the probability of A given B is defined to be the probability of A and B divided by probability of B. As you can see, this definition is consistent with our intuition for the exercises on the left. For example, let's look at problem 4. Probability of A given B is the probability of A and B divided by probability of B. Because A is a subset of B, then this is the probability of A divided by probability of B. This number can be smaller than 1. In fact, it can be 0. For example, if A is the empty set.